In this video we're going to look at the reactions of acids, in particular in relation to their balanced equations. So let's have a look at the first part, magnesium hydroxide and hydrochloric acid, and we're being asked to write a full balanced equation for that. So to get anything at all from a balanced equation, these are all worth 2 marks, we've got to get the right formulae of everything, because the balancing is a secondary mark. You only get the balancing mark if the formulae are right. So I'm just going to think about the charges on the ions. Magnesium's in group 2, so that's going to be a 2+, and hydroxide is the formula OH-, and hopefully I know HCl. So I'm then going to do my formula. So for magnesium hydroxide, I'm going to need 2 hydroxide ions, so it's going to be MgOH2. I'm going to react that with HCl. I'm not too worried about the balancing. You might have skipped ahead and worked it out if you're thinking about the ionic equation. That's fantastic. Meanwhile though, I want to make sure I get the right formula for my products. So chloride has a 1-, which means magnesium chloride is MgCl2. Water is the only other product. And then balancing, if you've thought ahead, there are 2 OH-, which means I need 2 HCl's because of the 1H+ goes with 1 OH- to make water. If I've got 2 H+ and 2 OH-, which I have here and here, then I will be able to make 2 water molecules. And the formula for my magnesium chloride is all fine because I've got 2 chloride ions in my HCl and I've got 1 magnesium ion. Hasn't asked for state symbols. I'm not quite sure what state symbols would be because magnesium hydroxide could be solid or aqueous, so we'll just have to leave that, although it's not very soluble, so it'd probably be a solid. Calcium and sulfuric acid is the next one. So calcium is just going to be calcium. A lot of people get confused about when they've been doing ionic equations. They want to start putting a charge on things like calcium in an equation, but calcium is just calcium, it's not in a compound. The only time I'd show calcium on its own, when we look at redox maybe, and calcium is displacing another metal. If it's in a compound like calcium sulfate and I take out the spectator ion, that's when calcium has a charge. Right now, calcium is just reacting with sulfuric acid. So the salt it's going to make is calcium sulfate. That works nicely because calcium is a 2+, sulfate is a 2-, so CaSO4 would be my formula. Another thing to spot there is notice that hydrogen has a +1 charge, so there are 2 of them there, and then calcium forms a 2+ charge, so you can always swap a 2+ ion, a group 2 ion, for 2 H+'s, or you can swap it in displacement for 2 group 1 ions. Whereas if you have a group 1 ion, that will swap exactly where the H+ is, because obviously they both have the same charge, +1. The other product is just going to be hydrogen. You can see that there is no water to be made here. There is no oxygen other than in the acid, and in the acid it's a sulfate ion. The sulfate ion goes in the salt. It doesn't go into water, the oxygen there. So really all that's happened is that my calcium and my hydrogen have swapped places. This is like a displacement. This actually is a redox reaction. And because it's a redox reaction, as a bonus, we're going to look at the ionic equation just to show how we would do it. So calcium, no charge, it's not in a compound there, it's just calcium on its own. The spectator ion is the sulfate because it's in a compound on both sides. So there's no change to my sulfate ion, it's solution, and then it stays in solution at the end. I'm not going to write H2 because that's uncharged, that's hydrogen gas. What actually happens when sulfuric acid goes in water is that 2 hydrogen ions for every molecule of H2SO4 are released into the water to go with the SO4 2-. So that's what's reacting with my calcium. Calcium in the right hand side is now in a compound, so I'd write it Ca2+, and then hydrogen gas, no charge on that. That is now a molecule sharing electrons, so don't remember that just because it's ionic, it needs everything to be ionic. Only the things that you're removing spectator ions from are ionic. Part C, iron 3 oxide and hydrochloric acid. So a bit more balancing going on with this one. Not a big issue though. So iron has a 3+ charge. Oxygen is in group 6, so it ends up with a 2-. So to get the formula of iron 3 oxide, I'm going to have 2 of my Fe3 pluses to go with 3 of my oxide ions. And again, I'm just going to write the formula of HCl without worrying about the balancing until I've done the other side. So what am I going to make? Well, iron 3 and H+ are going to swap over. So I'm not going to change the charge on iron 3 oxide. This is an acid-base reaction. This is not iron reacting with hydrochloric acid to make Fe3+. So Fe3+ stays the same. It's not oxidation or reduction. So if I've got Fe3+ and Cl-, the formula of my salt will be FeCl3. And then it's just going to be water. Nothing special about that. So the only weird thing is that there's a lot of perhaps more difficult balancing to do. So normally I would just might sit there counting ions, counting oxygens. What I'm going to do is use the balanced equation idea of the ionic equation. So in the ionic equation I have an oxide ion in my iron oxide. That reacts with H+ to make water. And so that means I need, for every O2- ion, I'm going to need 2 H+ ions to go with it, and that will make 1 H2O. On the iron oxide, I've got 3 oxide ions, so I'm going to need 6 HCl's because I need 6 H+ to go with 3 O2-. That's going to make 3 water molecules. So the hydrogen's now balanced, which gets nearly everything sorted. The only thing that's slightly different here is that we've got Fe2, which is quite rare, so there are 2 metal ions on the left-hand side. So I'm obviously going to need to balance that as well. That now sorts out my chloride ions. So again, if you were finding this really hard to balance, it means probably one of the formulae is wrong. And then the last one we've got is potassium carbonate and sulfuric acid. So potassium, group 1, carbonate, one of the ions we need to learn, sulfuric acid, definitely, oops, don't know why I wrote it so weird, H2SO4. So that means the formula of potassium carbonate is K2CO3. React it with my sulfuric acid. So this is a carbonate, so we're going to make carbon dioxide as well. Our salt, remember what I said, K+, 1+ ion, H+, also a 1+ ion. So I don't have to think too hard to know that the formula of potassium sulfate, the salt made, is K2SO4. Because if the formula of sulfuric acid is H2SO4, then we just swap in the K for the H. They are going to be exactly the same numbers. And then H2O is going to be made, and also CO2, and I haven't left enough space, so I will just put it down there. What I'm not going to do is put it over on the left hand side because that makes it look like a reactant. So if you run out of space on a balanced equation, keep everything on the correct side of the arrow. It's also going to help when you do reversible reactions and equilibrium. Okay, so lots of things going on, but remember that we said that basically when you take the CO2 out of a carbonate, you're just left with an O2-, which is exactly like the last equation that we looked at. So O2- reacts with 2 H+ to make H2O. Turns out it's balanced because once I've taken the CO2 out of this CO3 over here, I've got 1 oxygen left. Sulfuric acid already has 2 hydrogens in it, so I don't need any numbers in front to balance. Everything is already sorted for this one.